Hello children, welcome back to our class. What is the name of our lesson? What lesson we are going to discuss? The name of the lesson is metals and non-metals. What is the name of the lesson? Metals and non-metals. Right? So here in this lesson or from this lesson, in last class we discussed about the alloys. What we discussed earlier? We discussed about the alloys, right? So what are the what is mean by the alloys, and what are the alloys we are using in our day-to-day life? What are the properties of the alloys, and how we are using the things which are made with the alloys in our day-to-day life in industries and automobiles, how they are using and how they are helpful to us. These are all things we discussed in the last class, right sir? So now in this class we are going to discuss about the uses of metals and non-metals, uses of metals and non-metals, right? Here let me see that here first about what's are here uses of the metals. Let me see about uses of the metals. Are you clear? Here already we learned what is mean by the metal and what is the definition of the metal, where these metals are present in the periodic table. These all things we discussed in previous classes, right? Now we are going to discuss about the uses of the metals, uses of the metals. So here so many number of metals are there. Already we discussed so many number of metals are there. So among that, so we are going to discuss a few metals. We are going to discuss a few metals. So those are what's are here copper and aluminium and iron. So mainly these metals are very helpful to us in our day-to-day life. So how they are helpful to us and what are the things we are using which we are made up with these metals, let me discuss. First, if you take the metal, that is what's are here copper. What is that sir here? Copper, right? So copper is what's are here. It is a metal. Copper is a metal, and with the help of the copper, by using the copper here, so many things we are making. So for example, copper is used mainly in the electrical wires, and next with the help of the coppers we can make coins, we can make the coins, and we can make what's are here statues also. We can make statues, right? So like this so many uses are there for copper, right sir? So next we will discuss about what's are here. Next we will discuss about aluminium. Let me discuss about what's are here aluminium. So aluminium is a metal, and it is a very useful metal to human beings in their day-to-day life. So with the help of the aluminium, we can make what's are here electrical wires. We can make electrical wires and cables, and also it is used, to make what's are here so many utensils or so many cooking vessels which we are using in our houses, right? And with the help of this aluminium or the aluminium foil is used for wrapping of chocolates. It is used for wrapping of chocolates, and it is used for medicines, and what's are here cooking packaging of food. So aluminium foils are using in this ways, right sir, all of you? And the alloys of aluminium are used in so many ways. Aluminiums are used in so many ways. In last class we discussed, that is what sir, the alloys of aluminiums are very light and very strong. So due to this reason, the alloys are used for making of bodies of aeroplanes and what's are here bodies of aeroplanes and aircrafts. Are you clear? This is about what's are here uses of that is copper and aluminium. So let me take the one more metal, that is what's are here iron. Iron. So iron is also a metal. So it is used very widely in our day-to-day life. You all know about this. And with the help of iron, we can make what's are here tanks, and we can make screws, bolts, and nuts. Are you clear? And railings, and we can construct what's are here, bridges. We can construct bridges, and what's are here, the alloys of iron like stainless steel, like what's are here, stainless steel. With the help of that stainless steel, we can make what's are here, so many utensils which we are using in our day to day life. Are you clear, sir? All of you, that in a house we can, in our kitchen we can see so many things which are made up with stainless steel. For example, what's are here, plates, glasses, that means steel glasses, plates, spoons. Are you clear? So etc. These all are made up with what's are here, that is iron. That is what's are here, iron. So like this, so many number of metals are there, and we are using in so many aspects these metals. Are you clear, sir? All of you. So these are the uses of what's are here, metals. These are the uses of metals. Okay, children. So these are the uses of metals. Now let me discuss the uses of non-metals. Let me discuss the uses of non-metals, right? So what are the non-metals are there in the periodic table? So there are so many non-metals are there. So many non-metals are there. So among that non-metals, a few non-metals are very useful to us in our day-to-day life. So what are the non-metals which we are using in our day-to-day life, and let me see and let me discuss the uses of these non-metals. So for example, first I am taking, if we take what's are here, the non-metal hydrogen. The non-metal what's are here, hydrogen. So hydrogen is a non-metal. Hydrogen is a non-metal. And what are the uses of hydrogen means? So hydrogen is used for making of fertilizers. It is used for making of fertilizers, and with the help of what's are here, ammonia. With the help of ammonia. Are you clear? So next, hydrogen is also used in what's are here. Okay, children. So like this, hydrogen is used, like this, hydrogen is used to make what's are here, fertilizers. And along with this, the liquid hydrogen is used, as a fuel, in a spaceship, in what's are here, spaceship. So the liquid hydrogen is used as a fuel in spaceship, right? So these are the main uses which are these are the main uses of what's are here, hydrogen, right? So the next example I am taking that what's are here, carbon. The next example is what's are here, carbon. Carbon is, we know that it is a non-metal. It is what's are here, non-metal. So what are the uses of this carbon? What are the uses of carbon are there? So that means, so here we know carbon can show what's are here, so many types of allotropic forms. What is mean by allotropic? Already we discussed in the previous class. So carbon can show so many types of allotropic forms like diamond, graphite, and Buckminster Fullerene's coal, coke, charcoal. So these all are what's are here, allotropic forms of carbons. So in that, so diamond is one of the allotropic form of carbon. Diamond is one of the allotropic form of carbon. The diamond is used as what's are here, gem. It is used as a gem. That means it is used in the making of ornaments. It is used in the making of ornaments. And diamond is used. Diamond is also used as a cutter. Like that means diamond is used for cutting what's are here, marbles and glass. It is used as a glass cutter, and we can say that it is used as a marble cutter, right? So, and it is also, that means carbon, and it is also used as what's are here, fuel. Carbon is also used as what's are here, fuel, right? So next, the charcoal is used as, it is another allotropic form of carbon. So its symbol also carbon, that means C. The another allotropic form of carbon is charcoal. What is the another allotropic form of carbon? That is charcoal. So generally, charcoal is used as decolorizing agent in sugar industries. So what is the use of charcoal, sir, here? Charcoal is used as a decolorizing agent. It is used as a decolorizing agent in the sugar industries. So right. So these are the examples of these are the uses of carbon. These are the uses of carbon, that is a non-metal generally. So carbon, it shows a number of allotropic forms like diamond, graphite, and C60, that is called as Buckminster fullerenes, coal, charcoal. These all are what's are here allotropic forms of carbon. So just now we said what's are here graphite. So graphite is also allotropic form of carbon. Graphite is also allotropic form of carbon. We know that. So in last class we discussed that. What is that, sir? Here, graphite is a good conductor of electricity. Graphite is a good conductor of electricity. So due to its good conductivity, so it is used as what, sir? Here, it is used as electrodes in electrolysis process. Used as electrodes in the electrolysis process, and at the same time, the what is that, sir? Here, the leads of graphite. The leads of graphites are used in the pencils. Right? And if you observe the pencil and if you sharpen, you will get what's here a black color thing. So that is known as what's here, that is called graphite. That is what's here graphite. So graphite is an allotropic form of carbon. So like this, so many uses are there of what's here carbon, right? So the next non-metal, what is that, sir? Here nitrogen. The next non-metal is nitrogen. So what are the uses of nitrogen in our day-to-day life? Means are here the nitrogen compounds. The nitrogen compounds are used for the making of or preparing of what's are here fertilizers. The nitrogen compounds are used for making of what's are here fertilizers, right? And it is also used in the electrical bulbs. The nitrogen is used in what's are here electrical bulbs, and the nitrogen is used to store the human organs. Nitrogen is used to store what's are here human organs. Are you clear? So the next use of the nitrogen, so this is very important use, that is what's are here the nitrogen gas. The nitrogen gas is filled in what's are here chips packets. It is filled in what's are here chips packets. That means if you take the Lays, Bingo, like the chips you are eating, that chips, if you observe, it will filled with what's here gas. It is filled with gas. So what is the gas present in the chips packet? So what is the gas present in picture here? That is nitrogen gas. What is that, sir? Here nitrogen gas. So why they are filling nitrogen gas in that chips packet means, so the nitrogen gas prevents the oxidation. The nitrogen gas prevents the oxidation of food. So if the food which is present in the packet, if it is undergoes, if it is reacts with the oxygen, the food will spoil. What happens, sir? It will become spoiled. So to prevent that, so what happens, sir? Here they will fill nitrogen gas in the chips packets, and the nitrogen gas prevents the oxidation and it saves the food. Are you clear? So like this, what's are here different uses are there with the nitrogen. Are you clear, sir? So one more example I would like to take, that is what's are here oxygen. Well known non-metal. What is that, sir? Here oxygen. So what is the symbol of the oxygen? O. What is the symbol of the oxygen? O. So we know that, sir, here generally the living things are uses. The living things uses oxygen for breathing. Oxygen for what's are here breathing, right? So the living things, we know, if you take plants, human beings, animals, birds, whatever, these all are uses what's are here oxygen for breathing, right? So the next use is what's are here, it is also filled in the cylinders. The oxygen gas is filled in the cylinders, and that cylinder, the oxygen which is filled in the cylinders, that is used in the hospital. That is used in the hospitals for what's are here severe patients. For what's the whom are here severe patients. That means it is also used in the hospitals also, right? So these are the main uses of what's are here oxygen. These are the main uses of oxygen. So like this, so many what's are here non-metals are there, and they we are using in so many aspects. So among that, so many non-metals, we discussed here a few non-metals. That is what's here carbon we discussed, and nitrogen we discussed, and what's here next, that is what's here oxygen, like that, right? So these are the uses of metals and non-metals. These are the uses of metals and non-metals. Are you clear? So next, along with this, along with this, along with this, we will discuss about what's here. What is mean by corrosion? We will discuss about what's here. What is mean by corrosion, right? What is mean by corrosion, and what are the conditions to form corrosion, and how can we prevent the formation of corrosion. So these all things we will learn, right? So with the help of what's here activity, with the help of activity. So here, what is mean by corrosion? What is mean by corrosion? So corrosion is nothing but what's here, the reaction of metals, the reaction of metals with atmospheric oxygen and moisture, with atmospheric oxygen and moisture, to form what's here, a thin layer on the metal surface, a thin layer on the metal surface, right? So for example, if you take iron, for example, what's here, if you take iron, so what is the symbol of the iron here? That is Fe. What is the symbol of the iron, sir? Fe. So what is the Latin name of the iron? Ferrum. What is the Latin name of iron? Ferrum. So Fe, that is iron, Latin name is what's here? Ferrum. So if you take iron, when we keep this iron rod or iron articles or things, if you keep it outside of the home, so what happens here? They will react with the atmospheric oxygen. They will react with the atmospheric oxygen, and also they will react with what's here? Moisture. They will react with the moisture. They will react with, that means the iron things or the iron articles reacts with the atmospheric oxygen and what's here? Moisture, and they will react with that, and there is a formation of what's here? A reddish brown color. There is a formation of reddish brown color substance on the iron surface, on the iron surface. So what is the name of that reddish brown color substance? That is called as what's here? Ferric oxide. What it is called, sir, here? Ferric oxide, and generally it is known as what's here? Iron oxide. Iron oxide. So what is the chemical formula of that? Means Fe2O3. What is the chemical formula? Fe2O3, right? So this iron oxide will form on the metal surface when it is reacting with atmospheric oxygen and what's here? Moisture. So this total process is called as what's here? Corrosion. It is this process is called as corrosion. So whatever the ferric oxide is formed on the metal surface, that is also known as what's here? Rust. That is also known as rust. So what happens if corrosion takes place on the metal surface? What happens means, when the rust is formed on the metal surface, it will damage the metal. It will damage the metal slowly. So when it will damaging the metal, what happens here? The strength of the metal decreases. The strength of the metal decreases. Right, sir, all of you? So to prevent this corrosion, so here we have to follow so many things, or so many steps we have to follow. So what are the preventions of corrosion? Let me see in this class only later, right? So this is about what's here? Corrosion of iron. So for example, if you take copper, so we will observe the copper vessels in our home. We will observe the copper vessels in our home. So when the copper vessels are reacts with atmospheric oxygen and what's here? Moisture, they will also undergoes into what's here? Corrosion. They will also undergoes into the corrosion. That the substance which is formed on the copper, that is present in what's here? Reddish green. Reddish what's here? Green in color. That is known as what is that, sir, here? Copper carbonate. What is that, sir, here? Copper carbonate, right? And that means when copper substance undergoes into the corrosion, a reddish green color substance will form, which is known as what's here? Copper carbonate. Copper carbonate. Are you clear, sir? For example, if you take what's here? Silver. If you take silver, so in our homes, we will observe the silver utensils and the silver things and silver ornaments also. So when we are buying the silver ornaments from the shop, at that time they will glitter in good manner, right, sir? They will glitter in very good manner. After some days, what happened means, sir, here the glittering nature decreases. The glittering nature decreases. That means the shining nature, what happens, sir, here? Decreases. So why? Why? Means are here, silver is also reacting with what's here, atmospheric oxygen, and it also reacts with mainly the sulfuric acid which is present in the atmospheric, and then when it is reacting with that, sulfur or sulfuric acid, so what happens are here, there is a formation of, there is a chance to formation of silver sulfide. There is a chance to formation of what's here, silver sulfide. It will be what's here, a green in color. It is present green in color, right sir, all of you. So here these are what's are here different examples for the corrosion. Different examples for the corrosion. That means iron undergoes into the corrosion, and copper is also undergoing into the corrosion, and silver is also undergoing into the corrosion. Like this, so many metals are undergoes into corrosion. So when they are undergoing into the corrosion, what happens are here, there will be the decreasing of their characteristic property. Are you clear sir, all of you? Right. So now what we learn sir here, to undergoing into the corrosion of metal, what are required, mainly required things what are here, water, that means moisture, and what's here, oxygen. So let me see these things, what are the substances are required, for undergoing into the corrosion, to observe this or to know this, we will do an activity or we will observe an activity. So with the help of activity, we can understand in very easy manner. So let me see an activity. So what is that activity means are here, this experiment is proved that oxygen and moisture is required for the corrosion. For this, the materials required are 3 test tubes and 3 rubber corks, 3 iron nails, and what's are here, anhydrous calcium carbonate, and some oil. So first take the 3 test tubes and place 3 clean iron nails in each of them. And label them test tubes as A, B and C. Right sir, all of you. Now we have to fill some amount of water in the first tube, and next we have to close this with the help of the cork. And in the second test tube, so what we have to take means, we have to take a boiled water, some amount of boiled water. So in the boiled water, we have to add a few drops of water here, oil. Right? So first we are taking boiled water in the second test tube, and to the boiled water we are adding water here, few oil drops, and next we have to close that with water here with the help of the rubber cork. Right? So next, the third test tube. In the third test tube, we have to add water here, anhydrous calcium carbonate. Crystals to this, and next we have to close this also with the help of the rubber cork. So leave these test tubes for few days. So that means after few days, approximately, that is 3 days, what we can observe in the test tubes. So that means if you observe very closely that in the test tube A, what we are observing sir here, there is a formation of rust. Coming to the test tube B, there is no formation of what sir here, rust. That means it is not undergoes to corrosion. Coming to the test tube 3, there is also no formation of what sir here, corrosion. Are you clear sir? Are you observing the test tubes? So observe clearly. So in test tube A there is no corrosion, and test tube B, in the test tube A there is corrosion. So coming to what sir, in the test tube A, nails exposed to the both air and water. Due to this, the corrosion takes form. Coming to the test tube B, nail exposed to only water. So the oil layer is covered on the water, and it was here, there is no chance to formation of the corrosion. So coming to the test tube C, so anhydrous calcium carbonate is there. It will absorb the moisture which is present in the test tube. So there is no moisture, only water is present. That's why there is only oxygen is present. That's why there is no chance to form the corrosion. So this experiment proves that the presence of oxygen and what's are here moisture is required for what's are here formation of the corrosion, on the metal surfaces. Are you clear, sir? Anafi? Are you clear? So this is about what's are here activity. This is about activity what we discussed. This is about the activity. So this activity is proved that what's are here the oxygen and moisture are required. The oxygen and moisture, that means water, are required for what's are here corrosion. Right? Coming to once if we observe that what we observed here in the test tube A, there is what's are here water is present. Only water is present. That water, along with the water, what is there, sir? Here air also there. So due to that reason in the test tube A, the formation of rust takes place. Coming to the test tube B, we added what's here boiled water. So why we added boiled water means when we boil the water, the oxygen which is present in that, it will what happens, sir? Here evaporates. It evaporates, and that means the oxygen percentage decreases in the boiled water. So that means there is no oxygen, only water is there, right? So, and what we added, sir? Here some amount of oil added. Why we added the oil means, so the oil prevents what's are here occurring, that means passing of oxygen. So due to that, what happens, sir? Here in the test tube B also, in the test tube B, the nail which is present, that is not undergoes into the corrosion. Coming to the test tube C, so what is there, sir? Here we didn't add any water in the test tube C, and what we added, sir? Here we added anhydrous calcium carbonate. The anhydrous calcium carbonate, what it's happened means, so it absorbs the moisture. If any moisture is present in the test tube, so it absorbs that moisture. And what is present, sir? Here in the test tube C, only the dry air present. That means there is no any moisture. So with the help of this dry air, there is no chance to form what's here corrosion. So with this activity, we concluded that what's here to get the corrosion. So compulsory oxygen and water are required. So this is about what's here corrosion, and we proved like this. What's here what are the materials and what are the substances are required for the corrosion. I think you understand this. And next, what are the preventions we have to take? For corrosion, for not occurring the corrosion, right? So what are the preventions we have to take means here, generally if any metal things are there, so we have to keep away the metal substances from the air and moisture. That means we have to keep in our houses, right? We don't have to keep it out of the house, right? Next, we have to apply paints. For example, if any metal is present for what is that, sir? Here windows. If any windows or what's the doors like this are there, so what we have to do, sir? Here we have to apply paint, right? So what happens, sir? Here when we apply the paint on the metal surface, for example, if you consider this hand is metal surface, when we apply the paint on that, what happens? So the metal is covered with what's here paint. The metal is covered with the paint. If any moisture and oxygen is come near to the metal, what happens, sir? Here they come near to paint, but they cannot enter into what's here metal. That's why the metal is what's here safe. So, and we can apply what's here grease. We can apply grease also. Right? So these are the so many preventions, and and one more important prevention method is also there, that is known as what's here galvanization. What is mean by the galvanization? Galvanization is nothing but what's here applying of zinc coating on the metal surfaces. This is called as what's here galvanization. When we apply the zinc coating on the metal surface, the zinc layer, what happens, sir? Here it will protect the metal from the what's here corrosion. It will protect the metal from the corrosion. And one more method also we can use, that is called as what's here, electroplating. That is called as electroplating. So that means we can apply what's here, we can apply another metal layer on the metal surface by the electrolysis process. So what is mean by electroplating, and how can we apply the metal layer on another metal? We will discuss in the next topic. In this class only, right? So these are the prevention method. What are the first one? We can apply the paint, and we can apply the grease, and we can save what with the help of what's here, galvanization process. And next what's are here, that is electroplating. What is that, sir, here? Electroplating. Are you clear? So these are the different prevention methods to protect the metals from what's are here, corrosion. So this is about corrosion and activity for the corrosion. That means, and next, how can we prevent the metals from the corrosion? Are you clear, sir, all of you? So I hope you understood about this corrosion. So in this class, what we discussed here, we discussed about the uses of metals and the uses of non-metals in our day-to-day life, right? And next what we learn, sir, here, so what is mean by corrosion, right? And how can we protect the metals from the corrosion, right? And we observed an activity also. For what's here, corrosion. That means what are the things, that means what are the substances are required, that means air and water are required for undergoing into the corrosion. These all things we observed in the activity. Are you clear, sir, all of you? Right? So this is about what's here, today's class. So in next class we will discuss about what's here, another topics. So I hope you understand. Are you clear? So thank you.